So what we have here is the OSI 400 CPU board. This is reproduction board. I picked it up through Glitchworks on Tindy. This, like I say, is a reproduction of the original OSI 400 CPU board. This board is being configured to run a 6502 assembly language monitor. The idea being to put a 6501 processor eventually into the socket here. So the board has been configured for a Motorola 6800, which requires a two-phase clock and particular connections for the processor here. The MOS 6501 shares that same pin out, and that's why it's configured for a 6800. However, we're going to run, like I say, a MOS CPU in here. So we have the OSI 65A monitor ROM in place here, and that is a monitor for 6502 processor. So this is a 1702 EEPROM. It's 256 bytes. There's a simple monitor in here. There's an ACIA over here, a synchronous communication interface adapter, which provides the RS-232. Its baud rate set down here by this pot in 555. It's set at 153.6 kilohertz, which divided by 16 is 9600 baud. The transmit receiver simply brought over here to a pin header. I've got ground transmit receive hooked up here, and this is just a simple RS-232 USB adapter for a PC that has TTL I/O. So I'm not doing any kind of level translation here. It's just, it's just TTL level RS-232 connected to a Teraterm on a Win 10 PC. There's 1K of RAM here. These are 2102s. Page 0, 1, 2, and 3 live down here in these. This ROM's mapped up in the higher address space so that the reset vector up at the top of memory is there, and then the ROM runs up in that higher address space. There's some glue logic on here for making things work. There's an unused socket here that all kinds of different MOS chips could go into, depending on what you wanted to do with the board. There's a bunch of pull-up resistors here and here that are for pulling up the bus. Because I haven't configured this to go into an OSI backplane, it's in a standalone configuration. These pins have to be pulled up, via resistors themselves. So that's what those resistors are doing on the side. We're bringing in ground, +5 and -9. I modified a Meanwell power supply that was +5, +12, and -12 to instead output -9. That was done by replacing a 7912 regulator inside of the Meanwell supply with a 7909. There's a separate video on that. So this supply is customized to run this board. The CPU, of course, is in a ZIF socket here to make it easy to change out. Like I said, this is a 6512 that's in here. So it's pretty much pin compatible with the 6501 or a 68000. There's a slight bit of difference up here, I think on pin 39. That really doesn't matter for what we're doing. Boy, I'm just... Lots of noise there from the Win 10 PC. And then there's a reset switch sitting right here. So that's kind of really an introduction to the board. Don't know there's a whole lot else to say here. There's an empty socket here, I guess, or this empty socket could take another 1702 EEPROM if you wanted to. This is known as the M socket for monitor and the U socket for user program. Anything else I haven't explained here? I guess there's some open footprints over here for additional, logic devices or whatever. I just use one of those, like I say, for the TTL RS-232 I/O. I think that pretty much provides the introduction to the board. So with that, let's go in and see the monitor in action. So we've got Teraterm opened on the Windows 10 PC here, and it's using the USB to TTL level RS-232 adapter. We can look at the setup for that. If we look at the serial board, we're set to 9600 baud. Remember that the baud rate's set with the 555 and the potentiometer over here. It's set to 8-bit, none, and 2 stop bits. So it's 9600, 8, and 2. That 8 and 2 is the configuration that the 65A monitor will set the UART chip here to the asynchronous communication interface adapter, the ACIA chip here too. So let's go ahead and power the thing up. Oh, it is powered up. Okay, I've already got the power on, didn't realize it. Let me reset it. We saw a single carriage return happen over on the terminal screen. I can hit capital M now. It likes to be in caps lock to go to the monitor, and then we can do things like P0000. We'll start dumping memory. And this will continue to dump memory until we hit another key to pause it. We can then hit M to get back to the monitor. We can load data via L. So we'll load 0200 with FF 00, 01, 10, I don't know, 7E, E7. And I can continue on like this until I've got everything I want in, and then hitting R. So those were set in real time as I typed them in. Hitting R will stop that input and get back to the monitor. By the M key, I can hit P to dump 0200. And we'll stop here. And what we should see are the bytes I entered, and I do not see them. Isn't that interesting? FF0001, they're here, 107E, they're just offset. So the 00, or the FF is the first, is down here, the 00 is here, it is correct, 01 is here, the 10 is here, the 7E is here, and the E7 is here. So that's correct. That worked as expected. So let me get back to the monitor, and we're going to input a little program here, hopefully. I probably should have set this up ahead of time. So this little string right here is a little demo program, and let's see if I can get this loaded. So L0200. Sorry, this is kind of a pain. 0200, and that's going to be a 02, 00, 02, 00, 0F, E2, 00, BF, E4, C0, and there's something wrong here because it didn't all line up. So hard to do from their example here. Let me make some marks here to make this hopefully a little easier to do. So I'm going to get back to the monitor, and then I'm going to do a load again. That address is 0200, and I'm going to hit a space here. The space is out. There's a 20. R to get out, monitor, load 0200. It's always got to be a struggle. 20. I'm going to hit spaces between these. 00, I can, it doesn't matter. FE, 20. 0B, FE, 4C, 00, 02, and then I can hit R to get back to the monitor. So what I'm doing is over here, I'll show you, I'm entering that string right there, and I put some pencil marks in to make it a little bit easier to put in. So now that that's loaded, we need to set a start address. So we need to set the stack pointer to point at this. So to do this, we're going to enter, let me mark this one up to make it easier to do. So we're going to go ahead and we're going to load, let's get back to the monitor, we're going to load again to address 012D. We're going to load 28, 02, 00, and R. And that's when we hit the go command here, that it'll go there and run that. So it's going to jump to address 0200 to begin execution. So I can get back to the monitor again, and now I can hit the G key, and this should work. And what this should do for every key I hit on the keyboard, we should see that key echoed out twice, and we do. So this is working as expected. So that really does demonstrate the little monitor. Entering a program, dumping memory. I think I have to reset now to get back out and to get back into the monitor. We can dump 012D, and we should see our 280200, and we do. We can dump out 0200, and we should see our 2000 FE, etc. And we do. So there it is. There is a demonstration of the monitor. So the next step now here is to put the 6501 processor in and give it a shot. So I powered down here. I'm going to pull the 6512 out. This is really the meat that everybody is here for, is to see the 6501 in operation. There's the 6501 processor. Drop down into the 0 insertion force socket. Pin 1 is correct. There's a dot on the package, so it's in the right way. I'm not going to blow that up. And we should now be able to power up. Hit reset. I should see a return on the screen, and I did. And now if we do P0200, we shouldn't see our program anymore, and we don't. We see a 13B7, B9. So we're up and running on the 6501. So this 6501 processor I've got here actually appears to be a good processor. At least it's got enough working to be able to run the monitor here. So let's go ahead and enter the same program. So load 0200 20 00 FE20 0B FE 4C 00 02R. And if you think about it, P for punch, L for load. This is really expecting paper tape. It's kind of the concept here of what it's doing. Is it would be loading or punching paper tape. So I'm going to load address 012D with a 28, a D2. It's not a D2. I don't know why I thought that was a D2. 00R, back to the monitor, and let's do that again. Load 012D, because I just fat fingered that. 28, 02, 00. The address that it's going to be jumped to is the 0800. And did that work? No. Load 0, I typed an O here originally, 12D with a 28, a 02, a 00R, back to the monitor. You can see here that I am not well practiced. So 28D200. I still got the wrong stuff in that address. Load 012D. Why can't I get this right? 28 02 00 R that we're done. Back to the monitor. P012D 280200. Okay. And then do a P0200. And we should see 2000 FE 20 0B FE 4C 0002. So we should now be able to just hit G and go, and this should do the same thing. It should echo back 2 of every character I type so that we know it's receiving and sending something. So there it is. The character in and out in the ROM is being called. Character in to get a character from the keyboard, character out twice to print the double character out. And we're running on the 6501. That is very cool that I have a functioning 6501 processor from, I think, 1975, if I remember right, the markings on it. So let's go ahead. I'm going to power down here. Let the power die off a bit. I want to put as little time on this processor as possible. For obvious reasons, it's a precious part. Put the 6512 back in. Yeah, it looks like 34th week of 75. Get it up here where you can hopefully see it. And of course, we've got the TIM chip we've talked about previously. Well, I mentioned up on Twitter. Eventually, I'm going to convert this to use the TIM chip over here. And the TIM's got a monitor and serial drivers and stuff inside of it built into it. This is a 6530-004 TIM chip, and that's the idea where I'm headed with this, is do both of these chips work? And we're 50% there. We know the 6501 works. So anything else to talk about here? I think this really wraps it up. So I hope that was interesting. If you got this far, I appreciate it. And we'll talk in a future video.